Hello everyone and welcome to this pre-calculus course. In this lesson, we'll review what functions are and their main properties. Let's start by remembering quickly what a function is. A function is like a machine that is designed to do a certain process. You give it something and it gives you an answer. For example, this function is designed to count letters in words. I tell it a word, for example, tree, and the function counts the words and tells me the answer 1, 2, 3, 4. So the function would say 4. I can give it the word sun, for instance, and the function will say 3 because it has 3 letters. I can give it the word cat and it will also count 1, 2, 3, so 3. Alright, so the information I give to the functions are the inputs. That's what I put in. Makes sense, right? Inputs. What the function produces are called the outputs. Okay. The set of inputs that my function can accept is called the domain. Okay, so in this case, the domain of this function are words. My function accepts words. What happens to the function if I introduce it an image or a drawing, like this one? The function won't know what to do. Therefore, the smiley face is not in the domain because it doesn't know how to process it. Okay, the set of outputs that my function can produce is called the range. In this case, what is the set of outputs that my function can produce? Numbers, right? Well, which kind of numbers? It only produces positive integers. So the range is natural numbers. Alright, so this is the concept of a function. However, the functions we'll be studying during this year in math are not like these. They do mathematical operations. Let's look at this one, for example. This function is designed to multiply any input by 2. So it's designed to calculate the double of any input. You give it a 4, and the function will tell you 8, because the double of 4 is 8. You give it a 5, and the function will give you a 10. You give it a 7, and the function will give you a 14. Makes sense, right? What is the domain of this function? So these are the inputs. What is the domain of this function? So I gotta check. Can I give it any number? Yeah, I can give it a 0. The double of 0 is 0. I can also give it negatives. The double of -3 is -6. I can also give it decimals. For example, 2.4, I get 4.8. And I also can give it irrational numbers. The double of square root of 3 is 2 square root of 3. So the domain would be all real numbers, because I can give it integers, I can give it rationals, I can give it irrationals, and the range of this function is also all real numbers, because we're seeing that it can produce 0, it can produce positives, negatives, roots, etc. Alright, so what would be the proper nomenclature to describe this function? Remember that this function is designed to multiply any input by 2. So what the function does is multiply any input by 2, right? The proper way to express this would be the following. So we would give a name to the function, f, in this case for function. You could name it whatever you want. In brackets, we specify the name of the input. So I'm going to call it n for number, and then instead of writing input, we will express it with this letter we've previously defined. So this would be n times 2. Alright, it doesn't matter the name of the function or the name of the variable. Another way of calling this function could be g of x, I don't know, 2x. That could also be a proper way. These two functions are designed to do the same. You can name them however you want. Alright, there's going to be one condition for functions though we're studying, and that is that there can only be one output per input. A function cannot give you multiple outputs. For example, imagine a function where you input a word, for example, flower, and it tells you the number of letters that it has, so 1, 2, 3, 4, 5, 6, 6 letter, and it also tells you the first letter that it has, so that would be F. This will not be a function because I've given it one input and it has given me two outputs. we won't be considering this as functions. These are multi-evaluated functions, and we won't be studying them during this year. Here's another example. Look at this function. Fx equals plus minus 3x. So this function, you give it an input, for example 2, it multiplies it by 3, so 2 times 3 is 6, and then it gives you the positive answer and the negative answer, because there's a plus minus. This, we won't be considering this a function either, because it creates multiple outputs. How can we tell if a graph belongs to what we consider functions? Let's take a look at it. Let's take a look at this graph. Does it correspond to a function? So, to check this, we perform the vertical line test. We draw a lot of vertical lines, and if we see just one single line that crosses through more than one point, boom, 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 see, it happened here, then this is not a function. Why? Because for this input, I don't know which value this is, let's imagine this is 1, 2, 3, minus 4. When I've input minus 4, I've received an output here, 0, I've received another output here at 3, and I've received another output here at 4. So 3 outputs for just one input. We can do that. This is not a function. There can only be one output per input. For example, here. Okay, so this graph would not correspond to a function. Let's look at a graph that can correspond to a function. For example, this one. Here, if we draw a lot of vertical lines, all of them will only cross through one point. Great, let's continue. So now that we know what a function is, we need to study their domains. So, in general, studying the domain of a real function is pretty easy. Let's look at this one, for example. Fx equals x cubed plus 1. Remember, the domain is the set of inputs that my function can accept. And in general, mathematics works pretty well. We can operate anything. For example, can I plug in a 0 here? Yeah, sure, no problem. F of 0 would be 0 to the cube plus 1, so that's 1. No problem. Can I input a 2? Yeah, why not? 2 to the cube plus 1 is 9. So, in general, functions can accept any real number as their domain. So, in general, the domain of a real function would be all real numbers. However, there are some cursed operations in math. And these are the only two operations that, at least for now, you have to keep in mind. The cursed operations are, first of all, dividing any number by 0. That is problematic because it is undefined. We cannot divide numbers by 0. And the other cursed operation is putting negatives inside even roots. That's also pretty cursed because we know that we cannot evaluate them. So, what would happen if you had a function like this? 3x plus 1 plus x cubed. So, if I'm starting the domain of this function, I need to realize which inputs I can give it. So, in general, the domain is all real numbers, but here I realize that I'm facing one of these two cases. In this case, I have a division. So, I gotta be very careful because I cannot divide by 0. So I'm going to study what happens when the denominator is 0, because I know that can happen. I need to avoid that. If I solve this equation, I realize that when x is minus 1, I'm going to have a huge problem, because when I put a minus 1 here, I'm going to end up doing 3 divided by 0, and we cannot do that. Therefore, the domain of this function, and let's see how to express it properly, the domain of this function would be all real numbers, in general it works, except, so minus, the input minus 1. That would be the domain of this function. All reals except minus 1, because it breaks the function. Let's look at another example. So fx equals square root of x plus 4 plus 1 divided by x minus 6. Alright, So here we've got two problems when analyzing the domain of this function. First of all, I've got a square root. I gotta be careful because I know that this cannot be negative, and I've got a division, and I gotta be careful because I know that this can't be equal to 0. So from here I've got two things to study. First of all, I must make sure that x plus 4, so whatever is inside the root, and I must make sure that it is always 0 or greater. So 0 or positive, but never negative. That's the first thing I must make sure. The other thing I must make sure is that x minus 6 never equals 0. Or you can just study when x minus 6 will be 0, and then make sure that you don't put that input in the domain. So let's solve these two equations we're studying. First of all, x bigger or equal than minus 4. So from here, we've received one really relevant piece of information. From here, we're seeing that x must be greater than minus 4 or equal to minus 4. If you input something that's smaller to minus 4, the function will break. For example, if you put a minus 6, you'll get minus 6 plus 4, which is minus 2. That's a negative inside our square root. We cannot do that. It doesn't exist. The function will break. So the first condition is that I'm going to draw a number line. So this is a real number line. 0 is here, and minus 4 is here. Here would be minus 6, minus 8. 1, 2, 3. So the first condition that I've seen is that our inputs begin here and continue this way. But here, all of these inputs are empty. We cannot use them. But we've got another case we got to study. Let's see. So x equals 6. Be careful here, because when x equals to 6, that input is problematic. So here is 6. This input is not in the domain, so there's a hole here. We cannot put 6. Okay, how could we express this domain? We could express it like this. So we could say domain of f. It starts at minus 4. Minus 4 is included, so we used close brackets. If minus 4 was not included in the domain, we would use brackets like this. So it goes from minus 4 to infinity, right? However, there's an exception, add 6. Or you could also write it like x can be greater or equal than minus 4, but x cannot be equal to 6. Two ways of expressing the domain of this function, and like this, it's perfectly expressed. All right, let's continue with functions. General review. There are two types of functions we'll be seeing: odd functions and even functions. And for polynomials, it's pretty easy to analyze if they're even or odd. So for polynomials, if all the degrees of the variable are even, for example 6, 4, 2, we would say this function is even. Easy, right? The coefficients don't matter. They can be positive, negative, and any number you want. If the function is a polynomial with odd exponents, we would say the function is odd. All right? Pretty simple. If the function is a polynomial with even and odd exponents, we would say it's neither. Neither. Okay. Nice. All right, let's continue. So, in this graph, I've represented f. We're going to be seeing some things about f. So, first of all, what is the y-intercept of f? The y-intercept is the point where it crosses the y-axis. In this case, the y-intercept would be here. So, imagine this output is at 1, 2, 3, 4, 5, 6. We would say that the y-intercept is at y equals 6. What is the characteristic about the y-intercept? The thing is, whenever a function crosses the y-axis, the x value, so the input, will always be here. And what value is this? This is a 0. So always, to find the y-intercept, what we do is substitute the input for 0. In other words, perform f0. That's how we found the y-intercept. That's for the y-intercept. What about the x-intercept? The x-intercept, in fact, there is 2 for f. They're here and here. One is positive and the other one is negative. How do we find the x-intercepts? The thing is that for the x-intercepts, the function, the outputs are 0. So the x-intercept happens when the function is equal to 0. There's a difference. The y-intercept is putting a 0 on the variable. The x-intercept is making the function equal to 0 because the outputs will be 0. Let's look at an example. For example, this function f(x) equals square root of x plus 4. Okay, let's find the y-intercept and the x-intercept. So for the y-intercept, we substitute the input for 0. So let's perform f0, and that will be square root of 4, so 2. I've substituted x for 0, so 0 plus 4 is 4. Alright, so that's the y-intercept. The y-intercept is at y equals 2. Nice. What's going on? Okay, x-intercept. X-intercept means making the function equal to 0 and solving it. So that would be x plus 4 equal to 0. And now let's solve this equation. How do we get rid of the square root? We change it to the other side, raising whatever we have to the power of 2. So let's finish. X plus 4 equals 0 to the power of 2, which is just 0. So x equals minus 4. Therefore, it crosses the x-axis at input minus 4. And we're done. We've analyzed the y-intercept and the x-intercept. Great. One last example. For this function, how could we find the x-intercept? So the x-intercept means making this function equal to 0. We already saw that. Realize that the denominator will disappear, because when I move this to the other side multiplying, it will multiply by 0. Therefore, it will disappear. So I'm just going to get rid of this. So where are the x-intercepts? If I get rid of this, we end up with x plus 4, x plus 3, and x minus 1 equals 0. It is really easy to solve this equation because it is already factored. Which are the solutions to this equation? Look, if I put a 1, I solve this equation because 1 minus 1 is 0, 0 times whatever is 0, and I'm making this equal to 0. So x equals 1 is a solution. Who else is a solution? Minus 3. X equals minus 3. And who else is a solution? Minus 4. So whenever you have a function or equation that's already factored, it's really quick and immediate to solve it. So here are the 3 x-intercepts. In theory, now we got to check what the domain of this function is. Because maybe some of these results that we got are not even in the domain. Let's study the domain of this function. So there are 2 things that are bothering us. First, we got the square root of x plus 4. We must make sure that this is never negative. So let's study this. X plus 4 bigger or equal than 0. If I solve this, I get to this conclusion. Sorry, that it must be bigger or equal than minus 4. In this case, all these results are bigger or equal than minus 4. So looks like we're good to go. No problem for this. But there's also another condition. The square root thingy was in the denominator, and we know that the denominator cannot be equal to 0. So the second condition, watch out, is that x plus 4 square root cannot be equal to 0. So we're going to study when this happens. I get rid of it, power of 2, so x equals minus 4. Careful, because we cannot use this input. And we have it right here. So this is not a valid x-intercept. Why? Because x equals minus 4 is not even in the domain, so you cannot even use that input. It won't cross here. Even though it seemed like it would be one, there isn't. Alright, so I think this is everything for this lesson. you must also review the properties of exponents. I'll add another video that reviews them. Good luck. If you have any doubts, tell me.